let's look at how to solve joint variation. Joint variation is the combination of the direct and the inverse variation. So in this example, they said that you should find, so if x varies directly as y and inversely as the squared of z. So you need to write this expression as x varies directly as y and inversely as the squared of z. So you can see that there's a combination of direct and the indirect or the inverse variation in this question. That makes it to be called joint variation. So we need to use the values of the x, y, and z here to get the equation connecting these variables. Before that, we change the proportionality here to be k, that's the constant of proportionality. And we're going to say that x is equal to k y over z squared. Then when x is equal to 4, then y is equal to 3. So we have 3k here and 2 squared here. We are going to work further. 4 equal to 3k over 4. Cross multiply, you get 16 equal to 3k. Divide both sides by 3. You're going to get 3k equal to 5.3 approximately. So you approximate to 5.3. Then the equation, therefore, the equation connecting the variables. So you substitute the k into the relation here, and that is it. So we have x equal to 5.3y over z squared. And that gives you the relation or the equation connecting to the variables. That is it. Let's look at the second question, and it is a past question called mathematics in WASI. And this question says that we should R is doubled and Q is halved. And the directives are here said if P varies directly as R and inversely as the square root of Q. Let's first write this. So P varies directly as R and inversely as the square root of Q. So square root of Q. And we write this simple form, that is P equal to K R over square root of Q. All right. Now we solve the first problem. What is the effect of P if R is doubled and Q is halved? So we need to first find our new R. When it is doubled, we get 2R. And when Q is halved, so the new Q, you're going to get Q over 2. So you're going to substitute the R1 and the Q1 into this relation by getting our new P. So this one, I'm going to say that the P prime is equal to, so we have K, and the R1 becomes 2R, which we can say that 2RK over, then we have the Q to be Q over 2. This is the square root of Q over 2. All right, so we need to rewrite this as, so P prime equal to 2RK over root Q over root 2. So the denominator here will multiply the numerator up here, which are going to get P prime equal to 2RK root 2 all over root Q. Then try to rewrite this to look like the original relation here. And in this form, you are going to get P prime equal to 2 root 2 being multiplied by the original relation, which is KR over root Q. All right. So you can see the difference that we have gotten here, and that is the effect we are talking about. So if R is doubled and Q is halved, the effect will be P will be multiplied by 2 root 2. So therefore, the effect will be P multiplied by 2 root 2. All right, so that is the effect of P. Then we have the last one. He said, what will be the effect if Q is doubled and R is halved? So you say that the new Q, which we are going to use here So Q will be doubled. So 2Q, 2Q, and R is halved. So the new R, so R is halved. That is R over 2. So I'm going to substitute into the same relation, and we have our P prime again. So this one says QR, and we know R is, so we have K or R over 2K. That's the same. Then we have the denominator to be root Q, and root Q is, so we are having root 2Q over here. So we need to further work to simplify this. So we have P1 will be equal to then R, K, and these two will come down here to be 2 root 2Q. Then continue. This one will give you R, K over, then you split this 2 root 2 to be, so you have 2 root 2 will be this multiplied by root Q. So the same expression, all in the name of we want to get back the original relation. And this will be simplified as the P prime will be equal to 1 over 2 root 2 being multiplied with the original relation, that is the KR over root Q. And the effect is 1 over 2 root 2. So you can say that, therefore, the effect will be P multiplied by 1 over 2 root 2. All right, so this is how you can solve this problem. This is all about joint variation. We have other related problems that you can use joint variation to solve. In this question, if the further asks you to find any variable, either x, y, z, or whatsoever, we stand on this relation, you do substitution, then you find the variable. Thank you very much for watching. And also, don't forget to like, comment, and also follow me on TikTok. Please visit YouTube and also subscribe to my channel. Thank you for your time.